Math 98 Exam Review, Spring 2015, Part 6. You'll be expected to solve problems like these. Find the distance between points. Find the midpoint of a line segment. Describe a graph with an inequality statement. Use scientific notation. Use standard notation. Find a greatest common factor or find a least common denominator. First, let's find the distance between these 2 points. We'll use the distance formula to do this. In the distance formula, you subtract the x-coordinates, then you square those. You subtract the y-coordinates and you square those. Then you get the sum of that expression, and then you take the square root. So our x's are 8 and 2, so x2 minus x1 becomes 8 minus 2. Our y's are negative 4 and 4, so that becomes negative 4 minus 2. 8 minus 2 is 6. Negative 4 minus 2 is negative 6. Now we're going to square these. 6 squared is positive 36. Negative 6 squared is a negative times a negative. It's also a positive 36. Add those together, you get the square root of 72. If asked for a decimal, you can now use your calculator. An estimate for that is about 8.48528, so somewhere close to 8.5, between 8 and 9. But you may be asked to simplify that, in which case to simplify a square root, you will break the square down into, or break the radicand down to the product of a square, if you can find one. And in this case, 36 times 2 is 72. You can separate these, the rule of the product inside of a square root. You can separate the factors. The square root of 36 being 6, so a reduced form of the square root of 72 is 6 times the square root of 2. Find the midpoint of a line segment between 2 points. We'll use the midpoint formula this time. These are ordered pairs, where you find the sum of the x's divided by 2, the sum of the y's divided by 2. The midpoint is actually the average of the x's and the average of the y's. So 6 added to 4 over 2, and 7 added to negative 2 over 2 will give us 10 over 2 and 5 over 2. 10 over 2 can be reduced to a whole number 5. 5 over 2 is 2.5, but you may leave it as the reduced fraction. Now, to check this, you may want to plot the points in the coordinate plane. So this point is 4, negative 2, and this upper point is 6, 7. And then plot the midpoint, and what you see is that that midpoint lies exactly in the middle of that line segment, and that's why it's called the midpoint. Notice it is at 5 and 2.5. 5 and 5 halves is the same as 5, 2.5. Describe each graph with an inequality statement. We will use interval notation to do this. In the case of the first one, negative 3 is not included, but all points to the right of it are. So negative 3 with the parentheses means not included. All points to the right means we're going to positive infinity. Again, a parentheses to indicate not included since you can't reach infinity. And we always use a parentheses with infinity. So open circle, parentheses, the point where you start, the point where you end, and then close parentheses, always with the infinity symbol. In this case, we're going to start on the left and come all the way up until 3, and 3 is going to be included. So that's going to be from negative infinity to 3, 3 being included, so we put a bracket to indicate that. The third example, we're going to include negative 2 and go to infinity. So negative 2 included is a bracket, all the way to infinity, parentheses, always used with infinity. And the last one, we're going to come from negative infinity until we get to 4 and not include 4. So parentheses with the negative infinity and parentheses with a 4 to indicate open circle not included in the set of numbers. Write using scientific notation. Scientific notation is used for very tiny or very large numbers. For this first one, you will move the decimal between the 9 and the 5. That is the first non-zero digit. You put the decimal after that. So we have 9.55. We need to tell the reader, the person who sees the problem, that we're going to have to multiply by 10 to the negative 9 power. That is, divide by 10 to the 9th, which would move that decimal place back to the left. And if you count the decimal places between the original and where it is now located, you will get 9. So the negative 9 means divide by 10 to the 9th, which would move the decimal to the left, and therefore a very small number gets a negative exponent. And this first number in scientific notation has to be between 1 and up to 10, but not including 10. So 9.55 is correct. Large number can also be written in scientific notation. The difference here is that you put the decimal again behind the first non-zero digit, which is a 1, and then we write all the remaining digits. I remove the commas because we're now behind the decimal. We don't use commas behind the decimal. And we count the number of places between where it was originally and where it is now. And once again, we get 9, coincidentally. It could be any number, just depends on the number of digits. And this time, 10 to the 9th means we're going to move the decimal to the right 9 times, which would get us back to our original number. So a very large number will have a positive exponent indicating the decimal needs to be moved to the right to get back to the large number. Small number will have a negative indicating you need to divide or move the decimal place back to the left to get the original number. Using standard notation. So using what we just saw, when the exponent is negative, we're going to move it back to the left. 6 places means I need 5 zeros so that I'll have 6 places between where it was originally and where it is now. So it's a small number. We know that because it's a negative exponent. In the case of a positive exponent, move the decimal the number of places to the right indicated by the exponent, which is 8 places. We move that to the right. We're going to need 6 more zeros to have a total of 8 spaces behind the decimal. And then we can put commas to make it easier to read. So positive exponent, larger number. Now this is technically a very tiny number because that's a negative, but the absolute value is very large. Find the greatest common factor of these 3 numbers. We start with 12x to the 5th. We break it down as 2 times 6, x to the 5th. We can break this down as 2 times 2 times 3, so instead of 6, we write 2 times 3, x to the 5th. Now we have the prime factorization. There are no other factors for 2, 2, or 3 besides 2, 3, and 1. So we can move to the next one. Or we can write it as an exponent first because 2 squared is 2 times 2. Now we move to the next one. 20x to the 3rd. 2 times 10 times x to the 3rd. And I could have picked 4 times 5. It doesn't matter which you pick initially. I just picked 2 because it's easy. 10 is then 2 times 5. And then we can write with an exponent 2 to the 2nd times 5 times x to the 3rd. 18x to the 6th. 2 times 9, x to the 6th. 2 times 3 times 3, x to the 6th. Is 2 times 3 squared, this time because there are 2 3's, times x to the 6th. Now we can find the least common denominator. The greatest common factor. You look to see what they have in common. They all have a 2. They do not all have a 2 squared. So the first factor I would write down as a 2. Then I look to see what other factors they have in common. They all have x to the 3rd because x to the 5 means x times x times x times x times x. So there are 5 factors of x. But they all only have 3. So we look for the least exponent when you have a variable. So the greatest common factor that would divide evenly into these three terms is 2x to the third. Find the prime factorization, list the factors they all have. If it's a base, then be sure to list the lowest exponent because they can't all have it. If you pick something larger than x to the third, then this one would not have it as a factor. Find the least common denominator of each set of fractions. So here we're looking for a number that they will both go into. 7 and 2 will both go into 14. X and x squared will both go into x squared. Different from greatest common factor. In greatest common factor, the only thing these two have in common is a single x. But we're looking for the least common multiple, something they'll both go into. 7 and 2 will both go into 14. X and x squared will both go into x squared. So with the least common denominator, you list the highest exponent to the base. And here, x plus 2 and x minus 4 have nothing in common, so their least common denominator is the product of those two factors, x plus 2 and x minus 2.